What if the quiet, frozen world of Uranus still hides secrets, waiting to be uncovered? Just when we thought we had mapped its system, astronomers spotted something extraordinary, a brand new moon orbiting this icy giant. But this isn't just about one tiny moon. It connects to a much bigger story. From how our solar system itself was born, to the puzzling question of why we can sometimes see objects billions of light years away more easily than those in our solar system. But to understand all of this, we have to go back to the very beginning of our solar system. The birth of our Sun and the formation of the solar system began approximately 4.6 billion years ago with the collapse of a vast cloud of gas and dust. This cloud, known as a nebula, was part of a larger molecular cloud, a cold, dense region in space where gas and dust are abundant. In such environments, gravity causes the gas and dust particles to clump together. As gravity continues to draw in more matter, these clumps grow heavier, tighter, and more compact, eventually becoming what astronomers call dense pockets. These are the quiet embryos of creation, the hidden seeds from which stars ignite and planetary systems begin to take shape. Some of these clumps can collide with each other or accumulate more matter, strengthening their gravitational pull and eventually causing them to collapse under their own weight. As the cloud collapsed, it began to spin faster, thanks to a principle called conservation of angular momentum. It's like the universe's way of saying, if you're spinning and no one's messing with you, keep spinning. Most of the material was pulled toward the center of the disk, forming a dense core. As the core's temperature and pressure increased, nuclear fusion reactions began, marking the birth of our Sun. Around this newborn star, the leftover gas and dust flattened into a swirling disk, the protoplanetary disk. Inside it, tiny grains collided and stuck together, forming pebbles, then rocks, and eventually larger bodies called planetesimals. These planetesimals collided in violent impacts, some breaking apart, while others merged into ever larger worlds. Think of it as cosmic bumper cars, but with way higher stakes. Closer to the Sun, the heat was too intense for ice or gas to survive, so only metals and rock could build planets. That's why Mercury, Venus, Earth, and Mars became small, rocky worlds. Far out, where it was colder, ice could form and mix with gas. These conditions allowed the giant planets, Jupiter, Saturn, Uranus, and Neptune, to swell into massive worlds with thick atmospheres. As they grew, the planets organized themselves. Heavy elements like iron sank into their cores, while lighter materials floated above. Earth's iron heart created its magnetic field. Mars, being smaller, cooled quickly and lost much of its internal activity. Uranus tilted so dramatically that it rolls around the Sun on its side. Imagine a planet that just gave up on standing straight. And scattered among them were leftovers: asteroids, comets, and moons. Some moons formed alongside their planets, while others were captured wanderers from that chaotic, violent era. Uranus's newest moon may be one of these survivors. Recently, astronomers using the James Webb Space Telescope spotted a brand new moon orbiting Uranus. It has now been confirmed as the planet's 29th known moon. But this discovery wasn't by chance. The team captured 10 long exposures, each lasting 40 minutes, then carefully stacked them to reveal the faintest moving points of light. This tiny moon, provisionally named S/2025U1, is incredibly faint, far too dim for even the Hubble Space Telescope to see, and long hidden from Voyager 2's flyby in 1986. Based on its brightness, astronomers estimate it's only about 10 kilometers across, orbiting roughly 59,000 kilometers from Uranus's center, with a nearly circular path that takes about 9.5 hours to complete. Yes, a moon smaller than some cities. Space really doesn't care about scale. Now comes the paradox. We can detect galaxies billions of light years away, planets orbiting stars hundreds of light years distant, and even thousands of light years from Earth. Yet a moon in our own backyard remained hidden until now. The answer lies in how we observe, and in a subtle effect of distance. Nearby objects like small moons don't emit their own light. They only reflect faint sunlight. From Earth, they're hard to pick out against the glare of their host planet. It's like trying to see a speck of dust floating right next to a street lamp. Plus, because they are close, they appear to move relatively fast across the sky, making them even trickier to track in the dark. Distant objects, on the other hand, benefit from both scale and perception. Galaxies shine with the combined light of billions of stars. And because they're so far away, they appear to move extremely slowly, almost frozen, making them easier to observe with long exposures. Exoplanets, meanwhile, are usually detected indirectly. The transit method, used by NASA's Kepler and TESS telescopes, watches for tiny dips in a star's brightness as a planet crosses in front. The radial velocity method, measured with instruments like the HARPS spectrograph on the ESO's telescopes, tracks the star's subtle wobble caused by a planet's gravity. And sometimes, nature lends a hand. Gravitational lensing, observed with the Hubble Space Telescope, can magnify distant objects, letting us glimpse planets or galaxies that would otherwise be invisible. In short, it's not just distance that matters. Brightness, contrast, motion, and clever observation techniques often matter more. That's why a hidden moon near Uranus can be far trickier to spot than a galaxy billions of light years away. So, what does all this tell us? A faint moon around Uranus connects us back to the fiery birth of the solar system and forward to the mysteries of the wider universe. Each discovery, no matter how small, is a piece of the puzzle, a reminder that we are still learning how our cosmic neighborhood was built and how we fit into a universe full of wonders. Maybe, somewhere out there, another civilization is looking back at our sun, struggling to detect our world, just as we struggle to detect theirs. And hopefully they're not laughing at how much trouble we have spotting our own moons. And the best part? We're only at the beginning. With upcoming missions like NASA's Nancy Grace Roman Space Telescope, a wide-field complement to James Webb, the European Extremely Large Telescope, and potential future probes to Uranus, such as NASA's Uranus Orbiter, the next chapters may reveal things stranger than we can imagine. So here's the question for you. Do you think Uranus still hides dozens of undiscovered moons? Or have we nearly finished mapping its family? Drop your thoughts in the comments. I'd love to hear them.